Yeah, again, I would like to welcome Andreas Schopper and Bernd Hafner. They both are working at the federal state of Styria in the department 15, which concerns energy, housing, and technology. Chiara, could you please give the moderation role to Andreas Schopper now?
Yes, of course.
Mr. Schopper will start. He's in the section air quality, and Mr. Hafner is working in the section of energy, technology, and climate protection. And I also want to welcome my colleague Harald Messner, who is, like me, working in the team regions and municipalities in the Energy Agency of Styria. They three will tell us something about Austrian and Styrian main regulation initiatives and projects to control air pollution and emissions of combustion plants. So, Andreas Schopper, it's your turn. You can start.
Yes,
now.
Good morning, everybody. I'm just fighting a little bit to get the right screen. You cannot see the start of my presentation in the moment, do you?
No.
So how can I change between the screens?
I think maybe you have to go out again and choose the other screen.
Yeah, I'll try. That's not so easy. How can I go out?
Or you
I think you can choose between if you want to share a screen or an application. So I click on application PowerPoint and then it works for me. So
okay, so I still have some problems. So Paul.
Chiara, can you take back the moderation role?
I think just a moment. So yes, I think this should work. Does it?
Looks very good.
Yes.
Looks very good. Fine. Thank you. So good morning, everybody. As Heidrun already introduced in the following presentations, my colleagues and I want to give some information about the legal framework conditions for air quality and emissions in our province, and also some information about the regional improvement strategies. And this always with the focus on local and district heating networks. So I'm going to start with the air quality part, and as an introduction, I want to say a few words about Styria, because this is important for the understanding of our specific air quality situation. So Styria is the second largest of 9 federal states of Austria. It's situated in the southeast of Austria, close to the border of Slovenia. And wide areas of the province are situated in the Alps. So only 1/3 of the whole country is permanently settled. The capital of Graz lies in a wide basin in the extra-alpine, comparatively flat southeast of the country, and with about 400,000 residents in the whole agglomeration. It's the cultural and the economic center of the province. Graz and the whole extra-alpine part of the country have a long history of air pollution, not primarily because of the high local emissions, but because of very poor climatic conditions. Because the geographic position in the back of the Alps keeps away the upper air flows that come from the west and the northwest, and of course also the wind that's come from there. And it leads to a very poor ventilation and a high percentage of stable weather conditions, especially in wintertime, with no air change at all. So if you see an overview about the annual wind speeds and the frequency of stable conditions in some cities of Europe, you see that Graz, like for example Torino or Bolzano, is at the very lower end of wind speeds, and on the other hand has a very high frequency of stable conditions throughout the year. Just a moment. Yeah, so here you see a winter view from north of Graz from about 300 meters above the basin level. So in the back you see mountains of Slovenia, in the very back you see mountains even of Croatia, and in front you see the basin of Graz and you see bad air quality. So the first air quality regulations in Styria dated back in the mid of the 1970s when the problem was obvious, but in the 1990s the first national air quality regulations were enacted. So the basic law for the assessment but also the improvement of air quality in Austria is the Emissionsschutzgesetz Luft, which means pollution protection law, which is also the national implementation of the European regulations. This law defines limit values for various pollutants, and in many cases the federal limits are a little bit more strict than the ones of the European Commission's in the Commission Directive on Ambient Air Quality and Cleaner Air for Europe. Really challenging of these thresholds is to comply with two pollutants. The first is the annual mean value for nitrogen dioxide, a problem caused by traffic emissions that occurs in many urban regions in Austria and also in most of the member states. So this is not a specific Styrian problem. The second one is the daily mean value of PM10. We already heard about PM10 in the presentation before, which is a specific problem of bad ventilated regions. So the Austrian limit is set with, Austrian also the European limit is set with 50 micrograms per cubic meter as a daily mean value, with an annual tolerance of 25 days exceeding this limit in Austria, while the European directive tolerates 35 days, sorry. While NO2 is primarily caused by traffic emissions, the PM10 pollution shows a high impact of domestic heating, especially from solid fuel installations. So approximately 1/3 of the fine dust in Graz on high polluted winter days comes from wood smoke. This picture now shows you the trend of the annual exceedances of the PM10 daily mean value limit of some Styrian monitoring stations. The orange line shows you the tolerance of the European Commission with 35 days, and sorry, the red line is the European limit and the orange line is the Austrian limit with 25 days. Overall, the trend is very positive. So we started with more than 120 exceedance days per year in Graz when the PM10 measurements started in 2001. And after permanently improving the situation, we succeeded to comply with the Commission regulation for the first time in 2014. What you see is in the longer trend, the reduction on the emission side, while the short-term oscillation is more the meteorological input or impact. Following these high concentrations in the early years of PM10 measurements, the pollution in 2006 covered a very wide part of the country, so nearly all permanently settled areas were defined as redevelopment areas. With the improvement of the situation, the polluted areas got smaller. So recently, with the last change, only the extra alpine area and the wider Graz area is left as a redevelopment area. The efforts to improve the air quality situation started in Styria already in the 70s and the 80s, but the more ambitious programs focusing on the reduction of PM10 to meet the Commission limit started in 2004. The main pillars of the program are legislation, public information, and financial support. So Styria spent about 6.5 million euro per year since 2012 for improving the air quality situation. Besides the three other main polluters, traffic, industry, and agriculture, the program included various measures to lower the emissions from domestic heating. So for this workshop, I just pick out some of the approaches. So for many years, the city of Graz wanted a complete ban of heating systems with solid fuels in parts of the polluted areas, and especially the fresh air aisles in the surroundings, where the fresh air comes from the surroundings into the city. And all this in case of new construction and exchange of heating systems. But since this total ban appeared to be problematic because of legal considerations, the restrictions are now based on a very strict emission threshold. So solid fuels are not completely prohibited in the city or in these special zones, but dealing with the emission threshold needs a very low energy building and a very modern installation, like, for example, a pellet boiler, if someone insists on heating with solid fuels. In some of the higher polluted areas in Graz, there's also an obligation to connect to the existing district heating network. This contains urban residential areas that already consist, as well as areas changing from industrial to residential use, or also completely new development areas. This measure is again combined with long transition periods and also financial funding. As I already said, the financial support is one of the main strategies. So with this funding, the expansion of the consisting district heating networks in Graz So in some of the the funding enabled the expansion of the district heating network in Graz. It should therefore expand also into areas where a connection was not planned until then because of the high costs of this connection. But it makes sense because of a high substitution of old and highly emitting installation in the polluted areas. In the same direction goes the funding of district heating systems in the wider Graz area. As I already said, the wider Graz area is our main problem area with air quality in Styria. As these actions show, the focus is on strengthening, the focus especially in the wider Graz area is on strengthening the existing district heat systems. The use of renewable energy is an additional, but it's not the main target, since the heat supply for the whole agglomeration based just on renewables seems actually not possible. So besides the backbones of 2 power plants based on gas, there are efforts to use waste heat from industrial installations. So for example, the waste heat of a paper mill in the northwest of Graz and also from a steel factory in the city is actually fed into the grid. And for example, the waste heat from the city ice stadium and also the city sewage treatment plant is used for heating the city. The use of conventional biomass plants for local heating networks is locally limited because of the PM10 situation, but it's the common way in all the rural areas, even in the redevelopment areas. even the networks of some of the district centers, it's not a very fine map, but you see the centers in southeastern Styria, are supplied by biomass. But finding a suiting location for these power plants is not always easy. So in many cases, especially in the polluted areas, the compliance with the common emission regulations about them you will hear in the following presentation is not sufficient. So in the approval process, the impact of the plant on the local air quality situation has to be estimated. This is done by calculating the impact and the total pollution in the neighborhood with the use of dispersion modeling based on the project data, the legal emission thresholds, and the meteorological data. So in this example, you see a plant of a local heating network in southern Styria. You see the building of this plant and you see the chimney. And based on the technical project data you get from the people who want to build this installation and the maximum of the emission limits and the wind field data, the calculation is done. So it's always important the impact that occurs in the neighborhood from this pollutant. So in areas where the existing pollution is below the limit value, so the red line is the limit value and the green field is the local pollution, and everywhere where the existing pollution is below the limit values, the realization of a biomass power plant is comparatively easy as long as the calculated total pollution complies with the limit values. In case of the calculated total pollution exceeding the limit, a redesign of the project might make it approvable. So in this case, the compliance of the emissions of the installations with the legal emission regulations might not be sufficient. That's what I already mentioned before. This redesign can be done by technical improvements of the installations, like, for example, raising the chimney height or speeding up the exhaust gas. A reduction of the emission load is in most cases more difficult because small reduces, for example, of the PM10 concentrations are mostly possible, but stronger reduces might need additional filters, which can make a project too expensive and unprofitable. So in the worst case, a location can also appear to be unsuitable for a heating plant, although the boiler complies with the emission limits. The realization of a plant in a higher polluted or in a redevelopment area is even more challenging. So since the preload in these redevelopment areas is considered to lie already above the limit values, only a so-called irrelevant additional impact is tolerated. And this irrelevance is defined as 1% of the long-term limit value, like, for example, the annual mean value for PM10 or NO2, which is a very, very small contribution. So the realization of biomass heating plants for local heating networks in preloaded areas needs a very high technical standard. And in the best case, an optimally chosen location. So I finish with the air quality part now, and I would hand over to Bernd, but comments or questions are, of course, welcomed.